Thanks, Randy. Good to be back with the guest speaker series, this time as a presenter. Thank you so much for the introduction, and thank you to Central Region STI for keeping this great webinar series going. So this presentation on lakeshore flooding offers a deeper dive into the meteorological factors that contribute to lakeshore flooding. Over the last 3 years, our CWA, our forecast office in Duluth, Minnesota, we have been, we've been experiencing, an uptick in lakeshore flooding over the last 3 years. In particular, I'll be taking a deeper dive into 5 particular cases and looking at the meteorological factors. So for those that were able to attend the NWA annual meeting, you might have seen my 5-minute poster presentation on this very subject. So what you're about to see is kind of a director's cut, if you will, of this presentation, and a bit more information here than I was able to fit in for NWA. And a special thanks, before I continue, special thanks to my SU, Patrick Ide, and my WCM, Joe Moore, for their guidance throughout this research. All right, so why have we been having an uptick in lakeshore flooding? Well, the answer is pretty simple when you dive into the data. So these maps I'm about to show are from the Climate at a Glance from the NCEI website. So looking at the precipitation rankings by state. So this first one is the statewide precip ranking for the last 12 months. So right off the bat, you can see across the Lake Superior Basin, including the states of Minnesota, Wisconsin, and the UP of Michigan, we're all kind of within that 5, with like that top 5 ranking for wettest period. And Michigan actually did see their wettest 12-month period on record here. If we expand that to include the last 36 months, the last 3 years, things become even more stark. Now both Michigan and states of Michigan and Minnesota are now seeing their wettest periods on record. Wisconsin's just second place for that period. And if we expand even further, going back 60 months, basically every single state within the Great Lakes basin, except for Indiana and New York State, have seen their wettest periods on record for the last 60 months. So it's really no wonder we're seeing an uptick in lakeshore flooding threat, not just across Lake Superior, but across the Great Lakes basin, because we're putting so much water into that basin. In fact, across the Great Lakes, we've either seen new records broken or near records in terms of the all-time water level records. So, for example, Lake Superior last October of 2019 was just 1.1 inches below the all-time record for water level, and this is taken from the Duluth News Tribune. So you can see here, this is the water level trace for the water level station in Duluth Harbor. So you can clearly see, the uptick there at the very end when the winds start to increase, and we were just on the outside of breaking that all-time record. To put it in even more stark comparison here, looking at the last 3 or 4 decades, and basically comparing the monthly average water levels from the high point to the low point that we had. So you can see here, October 2019 monthly average was 183.88 meters across Lake Superior. The low point was in March of 2007, when the lake average water level was 182.79 meters. So in 13 years, that was a change of about 1.09 meters. So if we were to take that that change and convert it to kilometers, apply that by the area, which you can see here, slide 82,103 square kilometers. That equals a change of water volume of 155.99 cubic kilometers. So just how much water is that? Well, that's roughly equivalent to about 41.2 trillion gallons of water. That's enough water to fill approximately 62,412,742 Olympic-sized swimming pools. So an incredible amount of water being input into the Great Lakes, Basin, and in our case, Lake Superior. So in fact, if we look at the annual and the monthly water level traces, so the blue dots in this chart, that's the monthly average, and the flat blue lines, those are the annual averages. So the red horizontal line, that is the long-term average for Lake Superior. So over the last decade, you can see us going above that long-term average, and basically we've stayed there ever since 2014. And over the last 3 years, even in our lowest months in terms of water level, we haven't even reverted back to the long-term average. So, even despite as dry as we have been and our CWA this past summer, the water levels are still, quite elevated. So I want to shift gears away from the water level and talk about orography. So you might be thinking, well, what does terrain have to do with lakeshore flooding? Well, in our CWA, we have a very interesting feature that we have in terms of terrain. So hopefully everybody can see my mouse here, but along the north shore of Lake Superior, we have a very sharp gradient in terrain, a lot of cliffs and bluffs along the north shore. So if we have a east or maybe even a little bit northeasterly flow over the lake, we kind of get this what we call blocked flow, this mass convergence right along this higher terrain. And this flow will only accelerate along the favorable fetch along the southwestern arm of Lake Superior and right into the Duluth and Superior, Wisconsin area, which we call the Twin Ports. So it's not unusual in these kinds of situations for the wind speeds right here in Duluth to be a little bit stronger, maybe even 5 or possibly up to 7, 8 knots stronger than what many of the model guidance is showing. So this factor also contributes to the threat for lakeshore flooding in our region. So the cases that we looked at for the meteorological factors, there were 5 in total. Now I want to stress that these cases weren't exactly the most impactful, because actually, in fact, one of these resulted in no impacts, and we'll discuss more about that why later in the presentation. But these are certainly the 5 cases that really stick out in terms of our messaging. It had lakeshore flood warnings out across much of the shoreline areas. We enhanced our IDSS using our sit reps to message the lakeshore flood threat for our partners. So, and just to kind of keep the dates in mind, think of it like the first case starting in October 2017 and basically alternating between April and October, with the final case being October 21st, 2019. So when I say meteorological factors, what exactly do I mean by that? What exactly did we look at? Well, the factors that we tried to look at to determine if there were any thresholds or patterns to aid in our decision making for headlines. So we looked at, first of all, the residence time of the flow. That is, what is the duration of the winds across western Lake Superior? So when I say this, I mean basically when did the winds really start to ramp up and when did they start to weaken? In each of these cases, the winds intensified because of a strengthening mid-latitude cyclone that approached the region. So in all of these cases, it was actually very easy to determine when they started and when they stopped, because there really wasn't a gradual increase. It was very sharp increase in the wind magnitude, or in at least the flow across Western Lake Superior. Next, we looked at the magnitude of the flow. So was it more probable for the lakeshore flooding with winds of, falling within that small craft advisory range, or gale warning or storm warning criteria? So not only did we look at the actual magnitude of the flow, but we also looked at it in terms of headlines. What kind of headlines did we have in effect prior to the lakeshore flooding occurring? Next, we analyzed the forecast wave heights leading up to the event. Was there a particular wave height threshold that had to be met or exceeded to support lakeshore flooding? And then the fourth factor that we looked at, although not meteorologically related, but we looked at the water level. Was there a particular threshold that existed for lakeshore flooding to become more common? So the bulk of our analysis was performed at the Sky Harbor Airport ASOS, which you can see here marked in this Google map here. So the Sky Harbor Airport lies on this very thin strip of land here known as Park Point, which basically protrudes from downtown Duluth, and actually barely, there's a little gap here, but just about touches this area of land in northern Wisconsin. So Park Point, there's a lot of beaches, there's a lot of residences there as well. So a lot of the impacts that we saw from these events were right near the Park Point area and the aerial lift bridge, which connects Park Point to downtown Duluth, as well as areas up the North Shore, including some of the beaches like Brighton Beach and the Canal Park area, which is kind of right about here. So taking the data from Sky Harbor Airport as well as nearby observation sites, we were able to synthesize these patterns and these thresholds to try and determine, well, what was most likely values to lead to lakeshore flooding. So diving into the data, here we have the windrose plots taken from Sky Harbor Airport. Unfortunately, for the October 10th and 11th, 2018 event, they're actually, the wind sensor at Sky Harbor Airport was actually down, so I had to use a nearby substitute. But in any case, you can see that for nearly all of these cases, the predominant flow regime was from the northeast. Well, that kind of makes sense, especially if we had an east flow, given the blocked flow. However, the outlier was from the October 27th, 2017 case, where the flow regime was predominantly from the north. So one reason why we had the flow predominantly from the northeast was the mid-latitude cyclone tracks. A research journal by Melby et al. 2012 from the Army Corps of Engineers research archives concluded that most of the non-convective extratropical cyclones that led to lakeshore flooding, now across Lake Michigan, not Lake Superior, but for Lake Michigan, took a southwest to northeasterly track. So did we see something similar to that? If we had our track from like southwest and northeast to our south, it seems reasonable for us to have, for that to lead to lakeshore flooding across western Lake Superior. So let's see if we see something similar to Melby et al. 2012's findings. So this slide, hopefully the GIFs will translate well, but I know that there's quite a bit of GIFs here, and I don't want you to focus on these are taken from the ensemble situational awareness table, of course, looking at the mean sea level pressure. But don't focus on the climatological percentiles or the standardized anomalies, but instead just focus on the actual track of the surface low. And to aid in the analysis, I drew in the arrows here to show the track of these surface lows. So you can see there's a bit of variability in the tracks here. So, some of them showed a very similar track that Melby et al. 2012 had from southwest to northeast. However, there were a few, like say the April 13th through 15th, 2018 Lakeshore flood event, where a area of low pressure developed out of Wyoming through Lee cyclogenesis and kind of translated through the Corn Belt states, basically stayed to the south of the region. Yet we saw, quite a bit of impact from that particular event. So the real key finding here isn't exactly the track of the low, but its location relative to the region. So you can see that pretty much all of these mid-latitude cyclone tracks stayed to the south of the region. And I mean, that makes a lot of sense, right? Given the cyclonic circulation around the surface lows. So predominantly that east and northeast flow regime over western Lake Superior. So kind of organizing all the findings into a single table. So the second column here, looking at the duration of the wind, basically when the winds start to ramp up and when they start to weaken as the surface lows depart. So quite a bit of variability is seen here, but you can see that at least for 4 of the 5 cases, a wind duration of 24 hours was very common. The only exception was that October 21st, 2019 event where it was only 16 hours. In terms of the magnitude of the wind, lots of variability here too, but in general, it seems like, sustained winds, generally 25 to 35 miles per hour, gusts to 35 to 45 miles per hour, seems to be kind of in that ballpark for for at least a common threshold for these 5 cases. And speaking of it, in each of these 5 cases, in terms of the marine headlines, we had gale warnings out for all 5 cases. Not we didn't have for any of them a small craft advisory. In fact, a few of them we upgraded to storm warnings for portions of our nearshore waters. And then finally, the wave heights leading up to the event. What did we have for forecasts? So on the low end, we had 12 to 16 feet. And of course, for the rest of the cases, we had 14 to 18 feet. One, we had 15 to 20 feet. So it seems reasonable that for us to use that 12 to 16 foot threshold in terms of the wave heights as kind of our a way for us as forecasters to kind of home in on. So again, the meteorological findings, like I said, that 24-hour mark seems to be kind of the most common threshold in terms of the duration of the flow. Magnitude, while showing some variability, was within that 25 to 35 mile per hour range for sustained winds and 35 to 45 for gusts. And for those of us in operations, that here's the converted numbers in knots. So in terms of the headlines, gale warnings were predominantly in effect for all 5 cases with some storm warnings, and then that 12 to 16 foot threshold resulting in lakeshore flooding. So from the meteorological factors, let's look at the water level comparisons. So from NOAA's tides and currents page, specifically from the Duluth water level station, I was able to download the water level data in CSV format and plug those into Excel to get this chart. So the common water levels that we saw for each of these cases, at the very least for Lake Superior water level, we had about 603 feet. All 5 of these cases exceeded that particular level. Now for a few of the cases, for 3 of the 5 cases, including the most recent one of October 2019, they had exceeded 604 feet. So it seems like, you know, for water level thresholds, and I know that this is, you know, kind of probably more of like a nowcasting kind of thing, but that 603 foot mark seems to be kind of, it was suitable minimum value, whereas your confidence increases as you approach or exceed that 604 foot water level. So from the meteorology to the impacts that resulted from lakeshore flooding. So this list along the left-hand side is, you know, just a variety of different impacts that could result from lakeshore flooding. And for our purposes, a lot of the impacts that resulted were specifically like shoreline erosion, damage to coastal infrastructure, you know, perhaps some damage and loss to property. So those are really the key impacts that we saw with these events. And by the way, looking at the monetary losses cumulatively among these 5 events resulted in about $28 million in damages. So that first case, October 27, 2017, this was really the one that really raised eyebrows, because as far as I know, it had been, you know, quite some time since we'd seen lakeshore flooding impacts. So you can see these pictures, the one on the left-hand side, results of shoreline erosion in the Duluth area, as well as the Duluth Lake Walk in the other picture along the, you know, to the right here. So the boardwalk, where, you know, which sees a lot of traffic during the tourist season, the summer months, that boardwalk, as you can see, has just been torn apart. From Duluth to the South Shore in northern Wisconsin, we did see some impacts there too. So the image in the lower left shows the results of shoreline erosion actually along a road near Herbster, Wisconsin, which is you know, right along the South Shore, as well as a highway here, Highway 2 in Ashland, Wisconsin, which you can see some water overrunning over that road and resulting in its closure. Moving on to the second case, so we didn't, from what I saw, we didn't have, you know, as many pictures into our office as the first one, but nevertheless, there was some really significant video and pictures that came in. So you can see here in this video along the right-hand side, showing a large wave actually hitting the aerial lift bridge that connects downtown Duluth to Park Point area, hitting the very bottom of that bridge. So usually from the water level to the bottom of the bridge is about 15 feet. So very significant waves, as you can see here. The next case, October 10th, 11th, 2018, you know, more inundation of nearby parking lots, the canal near the aerial lift bridge, additional shoreline erosion and damage to coastal infrastructure here that resulted in hundreds of thousands of dollars of damage. So now to the interesting case of all 5, the one that resulted in no impacts. So why was that? And you can see here from these webcams, the culprit, it was ice. You can see in the video on the right, already we've seen some really significant waves, but we had a large bit of ice that developed along the South Shore. For those that remember the winter of 2018-2019, that was an especially cold winter. So we had quite a bit of ice over Lake Superior. So a lot of the ice that had developed along the South Shore was actually pushed towards the Twin Ports area. And once it settled in, it helped to dampen these waves. So, you know, when I say forecast challenges, I mean, you know, there were some discussions about, well, is it going to dampen? Would this actually happen? Would these strong winds and waves actually break up the ice, and it'd be a non-factor? But as you can see, clearly there was quite a bit of ice that resulted in the dampening effect, and therefore leading to no impacts from the lakeshore flooding itself. Now the most recent case, October 21st, 2019, you can see in the pictures at the top is actually a comparison of shoreline near Brighton Beach, a beach just up the North Shore from Duluth, about a week apart. So before the storm and after, so you can see a lot of sediment and debris being pushed up this, along the shoreline, as well as just halfway burying this bench here in the lower left, as well as additional shoreline erosion and coastal infrastructure damage in the lower right. So what makes this particular case stand out was, of all 5 cases, this was the first where there was actually a WEA sent out by local partners, local emergency management. Specifically, this was for people on the Park Point to shelter in place. There was a lot of inundation around the lift bridge, like similarly to the other cases, but this time I don't know the exact specifics, but for this one, the WEA alert sent about 6:05 p.m. that evening, and you can see here in the picture over to the right, showing crews with the city of Duluth blocking off traffic to the area lift bridge and the Park Point area. So you'll probably notice a pattern in a lot of these pictures, a lot of these impacts. A lot of the pictures that we receive are right here in the Duluth Twin Ports area. And that's really easy for us to know the impacts here in Duluth, given the extensive webcam network that we have in place, also being the largest population center of our CWA. But that is not to say that nothing happens over the rest of Western Lake Superior. There are impacts, but what can we do in the Duluth Forecast Office to try and learn more about what the impacts that result from the lakeshore flooding? So during the process of this research, myself, Joe, and Patrick have actually joined a community of practice known as CHAOS, or the Coastal Hazards of Superior, which is made up of a variety of different agencies. So for example, Wisconsin and Minnesota Sea Grant, Minnesota Department of Natural Resources, and Wisconsin Coastal Management Program. So, and we've made it known that, we want to know, the impacts that result from lakeshore flooding. And the result of that is a really neat website here, which is called the Lake Superior High Water Spotter, which for those people that are curious, you can see, visit the URL down at the bottom of the slide. But this page allows people to take a snapshot, like using their smartphone, along the shoreline of Lake Superior, and then upload their picture along with the date and time and location that they took that picture. And this way we can kind of develop a online timeline of the impacts and the morphology of the Lake Superior shoreline. So I think that this will offer a great tool for us to kind of keep up to date on the impacts that result from the lakeshore flooding events. So with that, here's the reference for Melby et al. 2012. And with that, I'll take any questions.